Hello guys, hello Koshal. Welcome to my math tutorial session on kinematics. Okay guys, in today's session we'll be taking a look at practice question, Cambridge IGCSE GCSE additional maths, kinematic exam style question. So we're taking a look at application of differentiation in kinematics and applications of integration in kinematics. Let's get started with the first question guys. Okay, let me just go ahead and demarcate my board so as to I have enough space to complete all tasks, guys. Okay, so the first question I have here is the velocity time graph represents the motion of a particle moving in a straight line. So question A, find the acceleration during the first 5 seconds. Okay, so guys, we have to find the acceleration during the first 5 seconds. Okay, if you look at, let me just use my line, and you can see from this, this is the starting point 0. So this is 0 to 5. So this one we want to find. Now, since this is velocity time graph, so the slope on that velocity time graph, I mean the gradient, or better say the slope on that velocity time graph give you the acceleration. So it gives acceleration. This one, this is the slope. So just do your change in y and change in x. So that should give you the acceleration. So let's go ahead and complete that. So that's A. Now I'm going to complete the same here. So I can do change in y because that is the gradient. Do you want me to write gradient? Yeah. Okay. Let me just write acceleration. Change in y divided by change in x. Okay. So that is the slope. Okay. This one, this line here. So just do what is the change in y? So that's y2 minus y1. 16 minus 0. So 16 minus 0, that is 16. Okay. Divided by x2. This is 5 minus x1 0. So 5 minus 0, that is 5. So that is 16 over 5. So what is 16 over 5? Let me pick up my calculator. So 16 divided by 5 equals to 3.2. So the answer here is 3.2. This is acceleration. That will be 3.2 meter per second. Okay. So you can just write here for acceleration during the first 5 seconds. Let me just write it as A. Sorry about that. A during the first 5 seconds is 3.2 meter per second. Okay guys, that's pretty cool, right? So don't forget that this is velocity time graph. Okay, so slope on that velocity time graph give you the acceleration. So this is very first 5 seconds. This line here, this line here. Okay, let's go ahead with the next question. Find the length of the time for which the particle is traveling with constant velocity. So now guys, velocity is constant. Or better still, we can have maximum, minimum, or constant velocity when the acceleration equals to 0. That is the change in y over change in x. Better still, you can just write it as dv over dt because this is actually velocity time graph. So instead of using change in y divided change in, I just want you to from mathematical concepts. But if you are doing physics, you can also do maybe change in is the same thing. Okay, so I can replace my change in y, okay, delta y by v. Okay, so that is dv over dt, so something like change in v. Let me use the Maya. Don't forget that actually what we are considering application of differentiation, so it's something like that. I'm going to work on that more. Okay, so change in v, that is change in v, 16 minus 0, change in t is 5 minus 0, the same way I have it here. Okay, so now what I'm trying to tell you is that we can only have because this was to find the length of time for which particle traveling with constant velocity. So body move, that is the body move with uniform acceleration where greater equals to 0. Okay, so that's it. So this is acceleration. This implies this is so if this equals to 0, that is acceleration equals to 0. Is that clear, guys? Okay, so now let's go ahead and do that now. And now for which the particle traveling with constant velocity. So this one, this is the constant velocity. Let me just use this line. This is the constant velocity. This one here. So yeah, that it is constant. This one, the acceleration increases, then this is constant at this point. You want me to use laser, guys? Let's go ahead with laser. So from this point, so this horizontal line. Okay, so that's what we have there. So yeah, so what is the time? So that is 5 to 20. That's what we have there. Okay, so that is in between 5 and 20. So what do we have there? So that would be yeah, this one is not, I don't know why, I'm just trying to give you some concepts I'm not going to use this yet, okay? So when this is 0, so that's it. Hence the acceleration equals between 5 and 20. So what is the time at that point? So that is 20 minus 5, okay? So the time is, why don't you use implies? Yeah, that is 20 seconds minus 5 seconds. So let me just put second. So that gives us what, 50 seconds. And sometimes, so you said it's uniform. I don't know. Is it uniform motion? Yeah. Okay, uniform motion. So this is uniform. Okay, yeah, cool. So that's the solution to that one mark. So question C now. And this solution to B. This solution to A like that. Okay, question C. Find the total distance traveled by the particle. So this is velocity time graph. So area under velocity time graph gives the total distance traveled. So we're going to consider, I don't know, should I change it to blue? Sorry about that. Let me just change the color to blue. So here now we're going to consider the total area. Okay, so area under the graph that gives us the distance traveled altogether by the particle. So let's go ahead and use the line now. So from this is the plane shape and position. So find the area of this plane shape. So what is this plane shape? This is a trapezium, right? So just go ahead and find the area of trapezium, because area under velocity time graph gives you the total distance traveled, displacement, something like that. The only thing is that distance is scalar quantity, while displacement is vector quantity. Go ahead with this. So down direction and distance. Okay, so yeah, let's go ahead and complete that. So area of trapezium is half into sum of the parallel side. Like this, if this is A and this is B, that's the distance here. Let me just go ahead. The distance from this total distance here is like 24. Total distance here is from 5 to 20. That is 15. So here is 15. So A is 15 and B is 24. So B is 24. That is 24 minus 0. A is 15. That is 20 minus 5. That's 15. So that's A and B. Then times height. Height is 16 minus 0. So 16 minus 0, that is 16. So the height is 6. So that's what I want to do now. So let's go ahead and complete. Half into A plus B. That's area of trapezium, guys. So times H. So half times sum of parallel sides is 5. So that is half into, so a distance between this first one. So 20 minus 5, that is 10. 50, sorry, 20 minus 5, that is 15, plus 24 minus 0, that is 24. And the height is what? 16 minus 0, that is 16. So I think I'll just go ahead and use calculator to complete this. I don't need to waste much time. 15 plus 24 for 15 plus 24 equals to 39. So into 39 times 16. Yeah, this question is quite simple, right? Yeah, I'm going to solve a simple question today. Let's see, guys. Okay, times 16 times sorry about that, times half. 1 over 2 equals 2. So that is 312 meter. Okay, so that's it. So the total distance, if you like, you can use S to represent that. Okay, so 312 meter. Sorry about that. 312 meter. 312 meter. So guys, don't forget area under velocity time graph. Okay, guys, this is the end of the first question. Let's go to the next. Okay, guys, here is the next question. Particle moves in a straight line such that its displacement x meter from a fixed point at time t in second is given by x equals to 3 plus sine 2t, where t is greater or equals to 0. So find the velocity of the particle when t equals to 0. So the first question asks us to find the velocity of the particle when t is 0. Okay, guys, we have to find the velocity. Okay, so don't forget that you are given this is the displacement. Okay, and this is more like what, this is a science question, tricky question. Okay, guys, let me go ahead and demarcate my board in order to manage this space. Okay, so I'm going to start with question A here. Okay, guys, how do you find velocity? So let's just go ahead and don't forget that we are actually trying to take a look at the application of differentiation integration in kinematics. Okay, so now this is velocity. Okay, so anytime you are given displacement, when you differentiate the displacement with respect to time, then what you have is what? Velocity. So when you differentiate what? Displacement with respect to time, what you have is velocity. Okay, when you differentiate distance with respect to time, what you have is speed. Speed, distance, and time are scalar quantity. Velocity, displacement, vector. What it is. So this is velocity. So go ahead and differentiate displacement. So what I'm going to do now here, because I want to find velocity, so I'll go ahead and differentiate the displacement equation, which is trig function anyway. Yeah, so let's get started now. So velocity v, go ahead and differentiate. So that is ds. Differentiate the displacement with respect to time. That is over t. So you understand now? That's cool. So don't worry, we're still going to look at integration aspect of it. So don't forget that whenever you are given displacement as equation, go ahead and differentiate it. Then what we have is what? Velocity. Okay, so yeah, let me go ahead and differentiate this equation function now. So this function is a trig function. Okay, so when you differentiate the constant, what you end up is 0. Okay, so I have 0 here. So that gives 0. Differentiate 3 is a constant 0 plus. Now this is a sine function. When you differentiate, now this is function of function, so you are going to use chain rule. So at this point now, I'm going to keep algebraic function constant. So I work with the sine function. So when you differentiate sine, that will give you cos. Don't forget this is constant. So because I'm not going to waste my time, guys. I'm not going to waste my time trying to do du, dv. Guys, go ahead and watch my video on application of differentiation and integration. You learn this. So yeah, so first thing is go ahead and differentiate with respect to sine. So you have cos, y is equals to t. Then since this is differentiation, now multiply by differentiation of the algebraic function. So when you differentiate 2t, you have what? 2. So what do you have now? So what I have here is 2 cos 2t. 2 cos 2t. Okay, guys, pretty cool, right? Hope you know chain rule. If you like, go ahead and do du dv. Yeah, to be candid, what you have to do here is just something like du over the x times the y over the u times the u over sorry, the y over the u times the u over the x. But I'm not going to waste time, guys. You know how to do this shortcut, guys. Okay, so but if you need to learn more on how to go ahead go about differentiation, integration, different complex function, guys, go ahead and watch my video on integration and differentiation part 1 and 2. It's going to really help you guys. Okay, so yeah, that's what we have here. So that's what I have here now. Where t is greater or equal to 2. Okay, so yeah, so now but this one says that when t is 0 now, so therefore when time is 0, so what I should do here is I'll just slash this one here when t is 0. That is anywhere you see t, just put 0 here. So what do I have eventually now? I'm going to have 2 cos 2 times 0, that is 0. So 2 cos 0. So 0 is 1. Go to your calculator to confirm. Because 0 is 1. So 2 times 1, that is 2. So my answer will be what? 2 meter per second square. Sorry, per second. This is velocity per second. So that's solution to question 1. So let's go ahead with the next one. B part. Now find the value of t when the particle is first at rest. First at rest. Okay, guys, don't forget that particle is at rest at instant velocity. So when the velocity is at an instant, then the particle is said to be at rest. Okay, so that is velocity at an instant, that is velocity equals to 0. That at an instant velocity equals to 0. Okay, so that is the particle is at rest when velocity equals to 0. So now when velocity equals 0, by implication, mean that we should equate when you differentiate speed with respect to time, then you equate your solution to 0. And I have it from here. From here, I think I need to demarcate this board again so that I still have like C and D. So let me just go ahead and do this. Okay, so let's continue, guys. So I have my ds, the t here is 2 cos 2t here. So that is 2 cos 2t equals to 0. 2 cos 2t equals to 0. So don't forget that instance velocity equals to 0. and particle is said to be at rest when velocity equals 0. Okay, so I should equate 2 cos 2t to be 0. Don't forget, this is what we have here. Velocity equals to, this is the function for velocity from here. Sorry about that. This is the function. So equate this function to 0. That's what we are doing. And go ahead and solve for t. So we are asked to find the value of t, so we solve for t. So here now, divide both sides by 2. When you divide both sides by 2, I have cos 2t. Okay, equals to 0. Then divide both sides by cos. I like to just, yeah, so that's how we come about arc cos, guys. Because I'm looking for t, so you want to make t subject of formula. So the next is divide both sides by cos. So that you take arc cos of both sides. So arc cos of 0. So 2t equals to, so I need to use my calculator at this point now. Okay, guys, if you look at what we have here, let me show you something here now, so that you can work in degree, you can work in rad. But from this question t here, time is in rad, 3 pi over 4. So you better go ahead and work with rad now. So don't forget that to work with rad, if you can recall from my video on circular measure, you should know how to convert from degree to rad. Let me quickly teach you how to do that. Pick up your calculator. So the first thing for you to do is just press shift, then mode, then you display 1, 2, 3, then rad is 4. So press 4. So you are right. So my calculator is right now. So I'll go ahead and do arc cos of 0 in rad. Don't forget. So shift cos, where is cos? Arc cos of 0, so equals to. So arc cos of 0 is pi over 2. That is 90 degrees. If you are working in rad, sorry, in degree, that should give you the same is still applicable here. So what we have just to do is to go ahead and integrate the velocity. Okay, so and that's what I'm going to do now. Okay, so question C. Okay, so what we have here now, I have and another thing now we need to note here is that from question B, we have to find the value of t when the particle is first at rest. So we already have a time to be pi over 4 when it's first at rest. Okay, so now this also first come to rest. Okay, so we're going to take the limit from 0 to this pi over 4. Okay, so from the position O to this point. Okay, first come to rest. Okay, like here. When it first comes to rest, so you have 0 here. Okay, from this O position to pi over 4. So that what we want to do. So you take the limit. The limit it will be from 0 to pi over 4. So you integrate the velocity with respect to time. Okay, guys, I'm not going to waste much time trying to do this. Okay, and because you can see that this is actually the displacement. Okay, so if you integrate this, so your answer should be equivalent to that. But let me just tell you something now. If you want to integrate this or this function originally and plus c, then you need to go ahead and find the constants, and then it's still going to give you this. You can try it, but I'm not going to waste much time. So I know that if I should integrate the velocity, because I actually differentiated this to get this velocity. So when you integrate the velocity, you should return back to x. So this should give me x. Okay, so when you integrate this, you should have x. Okay, so you can now go ahead and that's the answer of integration of this with respect to time. When you integrate velocity with respect to time, then you should get x, this value back. Okay, because I differentiated this to get this 2 cos 2t. Okay, so then take the limit from 0 to pi over 4. Exactly, guys. Okay, so now don't forget that if you look at this question here, we have to find the acceleration of the particle where time is 3 pi over 4, and this is also pi over 4. So you already know that we are working in rad. Okay, so let's just go ahead and continue. So now what I have now is this x is now what now? So this is what I now have now. So 3 plus sine 2t, 3 plus sine 2t. So you take the limit from 0 to pi over 4. So you substitute when value of t is pi over 4 minus when the value of t is 0. So let's get started with that now. So this gives, can I just use implies? Okay, so this implies, I want to continue here. So the first one, just anywhere you see t, just put pi over 4. So the first part of the solution will be 3. Okay, plus, hope you are cool with my 3, right? Sine 2t So that is 2 into pi over 4. So that what you're going to have. 2 into pi over 4. Okay. Then I can close the brackets. And that is when t is pi over 4. Okay. Then minus when t is 0. So that would be 3 plus sine 2 into 0. So I'm going to take my calculator now and complete the solution accordingly. Okay. Yeah. So that's pretty cool, right? So don't forget to convert your from degree to function from degree to rad. Press shift, then mode, then you take 4, which is rad. Okay, so you can now go ahead and do this now. So 3 plus sine 2, open a bracket, pi over 4, shift, pi over 4. Then let me close that now. Then close the second bracket. Okay, so that is equals to, so that gives me 4. Okay, so this gives me 4. So 4 minus, that is the answer for this. 3 plus sine plus 2 sine pi over 4 gives 4. Okay, so let's go ahead with the second one now. 3 plus sine 0. Sine 0 equals to, so that gives 3. So what do you have here now? 4 minus 3. So 4 minus 3 is 1. So by implication, the distance traveled by the particle before it first comes to rest is 1 meter. Hope that is pretty cool. So let's go to the question 3D. Okay. So question 3D says that find the acceleration of the particle when time is 3 pi over 4. So don't forget your acceleration. To find acceleration, so we are going to differentiate the velocity with respect to time. So acceleration will be dv over dt. Okay. So and we are given this is at when t is what? T is 3 pi over 4 at that particular point in time. Okay. 3 over 4. Okay, so let's go ahead and do that now. So now I want to differentiate velocity. So what do we do? So we want to differentiate the let me just write the function there. So differentiate this with respect to time by dt. So what is the function? Sorry about that. I'm writing not that bad. So I just want to write the t here. You can write it like that. T the function over dt. Okay, so what is the function now? Velocity. So velocity is actually 2 cos, this is t. 2 cos 2t. This is velocity. So 2 cos 2 cos, okay, 2t. Okay, so that's what I want to differentiate. So let's go ahead and do that. Yeah, just read it out too. Then you can open your brackets down. So now this is function of function. So you differentiate with respect to trig function first, while you keep your algebraic parts constant. So I will only differentiate with respect to cos. Okay, don't forget. So when you differentiate cos, that will give you minus sine. So that will be minus sine 2t because you keep that constant. Okay. Then times differentiate the algebraic part now. No, don't forget this is chain rule. You should have something like dy over dx equals to dy over dv times dx, something like that. This is the shortcut, right? I think I emphasized on this. Okay, so differentiate 2t, that will give you 2, right? So now the final answer here will now be, yeah, 2 times 2 is 4, that is minus 4 sine 2. So we can put the value for t now. 2 into what is t? 3 pi over 4. Okay, so 3 pi over 4. Sorry about that, 3 pi, okay, over 4. So I can use my calculator to complete this task now. So what do we have here? So minus 4, I'll just plug everything in there. Minus 4 sine, open it, 2 into 3 pi, 3 shift pi over 4, then close this, then close this, plus 2. So that is 4. So don't forget this is acceleration. The unit is what? Meter per second square. So I have 4 meter per second. Okay, 4 meter per second square. Okay, guys, this is the end of this question. Let's go to the next question, guys. Guys, here is the next question. Particle P is projected from the origin O so that it moves in a straight line at time t in seconds after projection. So the velocity of the particle v in meter per second is given by v equals to 2t squared minus 14t plus 12. Find the time at which P first comes to instantaneous rest. Okay, don't forget, guys. Yeah, I don't know. There's more emphasis on instance or this instantaneous. What is instant? Okay, so guys, don't forget that particles at rest or at an instance when velocity equals to 0. So that is okay. So yeah, that's it. So velocity, just equate anytime you see something like at an instance, then make sure that it is velocity equated to 0. And so the velocity is given. This is the equation. Okay, so the function here is, yeah, this is what we have here. It's more like a quadratic function, right? Okay, yeah, so let's go ahead and find. Okay, so complete that task. So find the time at which P, the particle, first come to an instance. Okay, so that's that. Okay, so now at instance velocity equals to 0. So velocity equals to 0 at I need to write it at. No, I'm not going to write it. Sorry about that. So at an instant velocity equals to 0. Okay. So yeah. So what we should do here now is to equate. Go ahead and let me just. This is question I. Okay. So what we should do here is just go ahead and equate this equation. Okay. To 0. So minus 14t plus 12. So you equate 2t squared minus 14t plus 12 equals to 0. Yeah, you can go ahead and factorize this, but I'm not going to waste much time. 2 is common here, so 2 is a factor. I'm going to reduce it first, then I'll go ahead and factorize. So that will be 2 minus 7t. So when you divide through by 2, okay, then plus 6 equals to 0. Okay, guys, don't forget that if if this is not 0, you can't do it like this. If this were to be 1, something like that, then this will not work, because what I actually did is just like 2 into, it is like 2 into, so because you guys need to know what you are doing, so 2 into everything. So when you divide both sides by 2, then I'll still have this equation. But if this were not to be equal to 0, let's say equals to 2, then you can't go ahead and reduce this only. You have to, anything you do to the left hand side, you have to do to the right hand side. Okay, so don't forget that. So let me just continue. Okay, so yeah, now I can go ahead and use my shortcut now. So break this one down, tt. So 6 times 1 will give me 6, and I want product to the sum to be 7. So minus 6 times minus 1 will give me 6, so minus 6 times 1 will give me 7. So I can take it like that. So therefore I have t minus 6. So that's, you can, I know you know how to factorize, guys, especially this type of function, okay, whereby you don't need to use completing the square method or quadratic formula. Okay, so just go ahead and use your factor method. Yeah, so now from here, t equals to 6 or t equals to 1. T equals to 1 or t equals to 6. Now, guys, I now need to call your attention to something. Don't forget our very last question, question 2. That question says that when it comes to rest, first come to rest, something like that. First come to rest. And I use something like number line that first come to rest. That you are moving from 1 to 0 or something like that. First come to rest. So now, meaning that it can be 6 here now. So because this one says that find first come to instant rest, so that is 0 to 1, something like that. So we are going to take the only value we are going to take there is 1. So the only solution there will be 1. So even though you have 1 and 6, so your final solution will be 1. This is 6. I don't know why I'm writing 6 like that. Sorry about that. 6. Okay. So t equals to 1 or t equals to 6. So first come to rest when t equals to 1 second. So that's the solution. 1 second. Okay, so that's that. So guys, hope that is pretty cool. Can we go to the next question? So first come to rest at t equals to 1. Okay. So t equals to 1. Okay, so next question. Find an expression for the displacement of the particle P from 0, that is starting position, at time t in second. Okay, now we want to find an expression for displacement. and you are given velocity. So how do you derive displacement from velocity? You go ahead and integrate velocity. So when you integrate velocity, you get displacement. When you differentiate displacement, you get velocity. So let's go ahead and integrate velocity. Now, but you are not just going to integrate the velocity, because this one says that find the place. Okay, at time t. Okay, so not at an instance. So I will have used 0 to 1. So that will be indefinite integral. So this is indefinite integral. So not indefinite. This is indefinite integral. So let's go ahead and complete it. So go ahead and do this dt. Yeah, I think I'll be able to manage my body. Well, let me go ahead and demarcate. Let me go ahead and demarcate. So in case. So yeah, let's go ahead and complete it. So this will give me what? Displacement S. Okay. Yeah, so integrate. So what is the function? 2t square, okay, minus 14t. Yeah, because that's the function for velocity, okay? So you integrate that function. And this is a quadratic function. So I hope you guys know how to integrate. So you just add 1 to the power. So that will be 2 raised to power 3 over 3. So 2 into this, then minus, when you do 14, square this one, so that will be 14t squared. Then you divide by the power over 2, then plus 12t. Equals to 2 over 3 t cube. So when you do 14 divided by 12, that is 7, minus 7t squared, then plus 12t. So that gives us the we have to find the expression for this displacement. So expression for the displacement, so S equals to that. I don't need to write it again. If you want me to write it again, let me just go ahead. So that is 2 over 3t cube. Okay, 2 over 3t cube minus 7t squared plus 12t. So that's the function for the displacement. Okay, so let's go to the next question now. Find the acceleration of the particle p when t is 3. So at time t equals to 3, you have to find the acceleration. Don't forget that whenever you are given velocity, when you differentiate velocity, you get acceleration. Okay, so that's what we are going to do now. Then I have the equation already for the velocity, so I'll just go ahead and differentiate this function. Then the solution, the resulting solution will be the acceleration. So so from velocity equals to 2t squared minus 40t plus 12. Go ahead and differentiate that. So acceleration is, you differentiate the velocity, that is the v over the t. Now we have at a given point, so that is when t equals to 3. So when t equals to 3, t equals to 3. So when t equals to 3. So let's go ahead and do that now. So don't forget I'm differentiating now. So I want to differentiate, let me just write it. So t, I want to differentiate 2t squared, the 2t squared, okay, minus 14t plus 12, okay, over dt. So you guys are good with differentiation, so let's just go ahead and complete it now. So when you differentiate, you bring this one back, so that will be 4. 2 times 2, that's 40. So take away 1, minus 14. Hope that is clear, guys. Okay, so that's what I have here. If you differentiate this, okay, so when you differentiate constant, that will be 0, so plus 0. So now put anywhere you see t, just go ahead and put 3 there. So I have 4 into 3 minus 14. So 4 times 3, that is 12. So 12 minus 14. That is minus 2. So that's more like deceleration because it's negative number. Okay, so minus 2 meter per second. So you can just write your acceleration is minus 2 meter per second, or the acceleration is 2 meter per second, because if you use the word deceleration, then you can write it as 2 meter per second. So that's pretty cool, guys. So that's the solution. Guys, let's take a look at the next question, okay? Yeah, question 7. A particle is moving in a straight line such that its velocity v in meter per second at t seconds after passing a fixed point O is given as v equals to exponential 2t minus 6 exponential minus 2t minus 1. So the first question here says we should find an expression for the displacement, displacement in meter from starting point O of the particle after t seconds, okay? So now, guys, since we are giving velocity here and we want to find expression for displacement, so we are going to what? Go ahead and integrate. So now, but before I can do that, let me just go ahead and demarcate my board in order to manage what we have here well. Okay, so let's just go ahead with 7 Roman figure I here. So let me write the function we have here. So velocity is this exponential function, exponential 2t, okay, minus 6 exponential minus 2t, okay, minus 1. This is minus 2t anyway, you can see my handwriting. Okay, so now we have to find an expression for displacement. So by implication, you go ahead and integrate what we have here. So if you integrate the expression for displacement, so displacement s equals to, you go ahead and integrate velocity with respect to time. So v, I say with respect to time, go ahead and do v dt. Okay, yeah, okay. So that's what we have there. Okay, so let's go ahead and do that. This exponential function. So in exponential function, it's like you have garbage in, garbage out, guys. Garbage in, garbage out. Okay. So go ahead. What integrate exponential 2t? So you keep the first thing we are going to do is to integrate respect to exponential function. And exponential is garbage in, garbage out, right? Just go ahead and watch my video on. Yeah, go ahead and watch my video on differentiation integration. So yeah, based on exponential, so you have e exponential 2t. Now since this is integration, that will not be times inverse of the differentiation of the algebraic part. So 1 over the algebraic part is 2t, so that's 1 over 2. So that's the first part, minus 6 is a constant, so just leave that one there. So go ahead and integrate this also. When you integrate exponential minus 2t, it will return it back to you, okay? So minus 2t, okay? Then, since this is integration, it will now be times 1 over differentiation of the right part. That's 1 over minus 2. Because when you differentiate minus 2t, that will give you minus 2. Then when you integrate a constant, so that will be minus t. Okay. So another thing you guys need to know here is that we need to find the value of c, so plus constant, okay? But let's just leave that for now. Okay, so what do I have here now? So what do I have here now? So I have 1 over half exponential 2t. Okay, now this is minus minus, so that gives me plus. So that will be plus 3, right? That's plus 3. Minus 6 divided by minus 2, that is plus 3. So plus 3 exponential minus 2t. Okay. Then minus t. Okay, plus c. So how do we find the constant now? So when displacement is 0 at time is 0, then we can go ahead, we can find our constant. So to find c now, let me just write you have to put s, so put s and t to be 0. So put the displacement in the original function. Put displacement, sorry about that. Put displacement to be 0 and t to be 0 to find c. Guys, I'm speaking English, right? Okay, sorry. Well, I'm not going to write it. So to find, let me write it. Don't worry, I'm going to write it. So to find the constant. So to find c, to find the constant, to find c, put s and t to be 0 in the original equation. So yeah, in the function. So from this function we have here, from this one, from this s, so we want to find t now. So therefore, what do I have now? So I have half, because this is not the complete function. I need value for c. Okay, so we need value for c and we value. Okay, so half into exponential 0, because 2 times 0, that is 0, plus 3 exponential minus 0 minus 0, no problem, just use your calculator. Minus 0, okay, plus c, okay, equals to s, and s is 0, 2 equals to 0, equals 0. Okay, so go ahead and use, definitely exponential 0 is 1, so that's half. It's just exponential minus 0 I need to confirm. Yeah, guys, I'm not too smart, right? Exponential minus 0, because I know it should be 1, but I just want to confirm. So it's 1. So because, yeah, that's cool. So plus 3 times 1, that is 3, plus c, equals to 0. So therefore, you can see that c is 3.5. C is 3.5 or 3.5. But if you like 7/2. I don't know which one do you like, guys. 7 over. Let me work with 7 over 2 in proper fashion. So now, what is the speed now? So the final expression for the displacement is now half exponential 2t, okay, plus 3 exponential minus 2t, 3 exponential minus 2t, okay, minus t, plus 3.5, if you don't mind. That's 7/2. Or should I, let me just write that 7/2. So that's the solution to that question. So let's go ahead and put it in rectangular. So that's the expression for the displacement, guys. So this is the expression for the displacement. Okay, next question now says that using the substitution method, u equals to exponential 2t or otherwise, find the time when the particle is at rest. So guys, when you say particle is at rest, don't forget particle at rest when velocity is at instance, that is velocity equals to 0. So at an instance, velocity equals to 0, that's when particle is at rest. So that is Roman figure 2. So meaning that we should put v equals to 0 to complete that very task. Okay, so now velocity equals 0, and this is the expression for the velocity. So let's put exponential 2t to be 0. So put from that, because I'm not going to write everything. So let's put exponential 2t to be equals to u. Well, they asked us to do that or otherwise, but I will go with that. Is cool. So what do you have now? So let me just write this, then I will write it. So exponential 2t minus 6 exponential minus 2t, okay, minus 1 equals to 0, because that is the velocity, okay, equals to the velocity, technically. So when velocity equals to 0, and we want to substitute, anywhere we see exponential 2t, we should put u. So I have u minus 6, u inverse means 1 over u, so that's 6 over u, okay, because this is u inverse, u raised by minus 1, okay. So minus 1 equals to 0. So go ahead and find the LCM. So the LCM here is u, right? So then I'll have u squared minus 6 minus u equals to 0. So I end up with a trinomial, and that is the quadratic function. So I end up with something like u squared, sorry about that. So I end up with something like u squared minus u minus 6 equals to 0. So we go ahead and factorize this. Okay, I don't need to waste much time. Definitely this will give me u minus 3 minus 2. Yeah, minus 3 plus 2 and u. So I have one more question, so I don't need to waste much time here. Let me just go ahead and write the factorization. I'm going to have something like u minus 3 into u plus 2. So if you expand this one, you should get that. Okay, equals to, you guys are good with factorization, right? So from here now, I have u equals to 3 or minus 2. U equals to 3 or minus 2, right? U equals to 3. Sorry about that. 3 or u equals minus 2. Okay, but don't forget that from the onset, we actually put u to be this. So by implication, exponential 2t, okay, equals to 3. So we want to go ahead and find t. Don't forget that in order to eliminate this, just take ln of both sides. Let me put something in a rectangular box here, just for you to recall. Now, log to exponential base is the same thing as ln. Log to exponential base is the same thing as ln. So log is an operator, okay? Log to exponential base is the same thing as ln. So for example, you can press ln 1 in your calculator, ln 2, or log 1 base is something like that. So if I take log to exponential base on both sides, so anything you do to the right hand side, do the same thing to the left hand side. So I want to take this on both sides. Okay, so that would be log with 2t. And since don't forget that log to exponential base is the same thing as ln, so I can write this one as ln 3. Okay, because I can work with ln in my calculator. So therefore, this one will cancel out. 2t comes to the back, and log basically goes to 1. So you have 2t equals to ln 3. Okay, ln 3. And from here, and don't forget, I'm careful because I need to do the second one, but I know something. When you find ln of negative number, that will be undefined. So this cannot be a solution. So the only solution will be when exponential 2t equals to 3. So, but don't worry, I will still call your attention to that. So therefore, t is what? Half ln 3. Divide both sides by 2, that is half ln 3. Half ln 3. So if you want to repeat the same for the second one, when exponential 2t equals to minus 2, you end up with something like 2t equals to ln minus 2. And ln minus 2 is undefined. So that is not a real true solution. So the only solution is u equals to 3. Because it can't be negative value. You can't have negative value. So this is the solution now. So finally, find the acceleration at this limit. At this limit, that is when t is half ln 3. So we want to find the acceleration. Yeah, guys, this is pretty cool, right? So when you find out if acceleration is differentiated, go ahead and differentiate the velocity. And this is the velocity. Go ahead and differentiate this. Now at this point, I need to use. Oh my God! Sorry about pretty cool, right? So yeah, nothing is missing. I've been following before, guys, so no problem about that. But I don't have enough space, so I need to do that. So I'm sorry about that, guys. So let me go ahead with the last question here. So Roman figure 3 now. 1, 2, 3. So I want to find the acceleration. Therefore, to find the acceleration, A is go ahead and do dv dt. So differentiate velocity with respect to time. Okay. Now they say at this time, at what time? This one here. So at t equals to half ln 3. Half ln 3. Sorry about that. But my handwriting is pretty cool, guys. Half ln 3. Okay, so yeah, let's go ahead and do that now. So sorry about that. Differentiate this function here. Differentiate this function here. So what do we have now? So a equals to. So when you differentiate exponential, differentiate with respect to exponential. So that will be exponential 2t. While your algebraic function is constant. This is differentiation, so that will be times differentiation of the algebraic part. That's times 2. Then minus. This is a constant. Bring it out. Go ahead and differentiate with respect to exponential. That will be exponential minus 2t. Okay. Then times differentiation of the algebraic part. When you differentiate minus 2t, that will give you minus 2. Then when you differentiate the constant, that gives you 0. So minus 0. So now what do we have here now? So acceleration equals to 2 exponential 2t. Okay. So minus 2 times minus 6, that is plus 12. Plus 12 exponential minus 2t plus 0. So you can ignore that. So then I have what? 2 exponential. Now 2 times half, because I want to put half ln 3. half lane 3. So 2 times half will go to what? 1. So that will be exponential lane 3 plus 12 exponential minus 2 times half will be 1. So minus lane 3. So go ahead and plug this in your calculator now. So let me just go ahead and plug this in my calculator. So yeah, 2 exponential lane 3, 2 exponential lane 3, then plus 12 exponential lane minus lane 3 minus lane 3 close bracket equals to, so that is 10 equals to 10, and this is acceleration, so that should be meter per second square, so 10 meter per second. Alright guys, don't go away, just hang on guys, I need to show you something, just hang on guys. So this is the end of this question, just hang on.
Hello Aluko. Can you help publish the video on kinematics? I would like to go over it again after the class session. I will really appreciate if you can feature more GCSE, IGCSE examination style questions to enhance our learning. I mean, if possible, all contents required by the examination board for us to gain a deeper understanding of the syllabus, aims and assessment objectives.
Hello guys, immediately after this session, the video on kinematics will be available via my YouTube channel. There are quite good numbers of maths, additional maths, ICT, robotics and coding videos on my YouTube channel that will help you guys enhance your learning. If you find any of my resources and contents useful and cool enough, just go ahead and click like. Also, do well to hit the red button to subscribe to my channel for auto update of subsequent videos. It's free. Love you guys. Do have a great day ahead. Now, let's end with this note.
Break the streets.